I want you to picture this. You're sitting on an airplane, seatbelt snug, tray table half broken. There's a soft whoosh of air vents above you. Someone nearby is unwrapping a sandwich way too loudly. You look out the window, and suddenly it hits you. Outside that thin wall is air so cold and thin you couldn't survive there. Inside, totally normal. You're breathing, relaxing, maybe even complaining about the Wi-Fi. But wait, you're in a metal tube at 35,000 feet, full of pressurized air. That sounds less like transportation and more like an overinflated soda can. So why doesn't it burst? Why doesn't the cabin just pop? But here's the surprising truth. The airplane isn't fighting pressure. It's built to live with it. Today, we're uncovering why airplanes don't explode from cabin pressure, how engineers turned a deadly problem into a predictable system, and why every flight is actually a carefully controlled balancing act. To understand why an airplane doesn't explode from cabin pressure, we first have to look at the problem early aviation faced. When airplanes first started flying high, cabins weren't pressurized at all. Passengers wore oxygen masks. Flights stayed low. Turbulence was constant. High altitude, the place where planes are most efficient, was basically off limits. Engineers realized something. To make air travel practical, they didn't just need better planes. They needed to recreate Earth's atmosphere inside a machine. Here's the first secret. Airplanes are round for a reason. Think of squeezing an empty soda can. It's incredibly strong when pressure is evenly spread. Now imagine squeezing a box. Corners fail instantly. A round fuselage spreads the force across the entire surface. The shape itself is doing the heavy lifting. But if the body handles pressure so well, why doesn't the metal eventually weaken? Airplanes are not built to stay rigid. They're built to move. Every flight, the fuselage expands slightly as pressure increases, then contracts during descent. Just a few millimeters, but it happens thousands of times. Think of it like breathing. If the structure were stiff, it would crack. Flexibility keeps it alive. So if the plane is constantly expanding and contracting, how is that kept safe for decades? Cabin pressure is not stored like air in a balloon. It's continuously balanced. Air flows in from the engines, while valves release air at the same time. It's like filling a bathtub while the drain is slightly open. This prevents dangerous pressure spikes. Even the oval windows are part of this system. Early planes had square ones. They failed. Rounded windows spread stress safely. Nothing you see inside the cabin is accidental. Why go through all this trouble? Because flying higher saves enormous amounts of fuel. Thinner air means less resistance. Less resistance means lower cost. But higher altitude increases pressure stress. So aviation regulators require aircraft to survive tens of thousands of pressurization cycles. This isn't just engineering, it's economics. And strict certification laws. If a plane couldn't handle this, it wouldn't be allowed to fly. So next time you board a plane, don't see it as just a flying bus. See it as a machine solving one of the hardest problems in engineering, keeping humans comfortable in a place we were never meant to exist. You're not just traveling. You're inside a structure that flexes, balances, and adapts to extreme physics every second, quietly, invisibly, and precisely. If this surprised you, hit like and subscribe for more hidden stories behind everyday things.